All right, so today we are going to dive into something that, well, it really questions the very foundation of modern physics. We're all taught that the universe runs on these beautiful, elegant mathematical laws, right? But what if that whole idea is just a grand misunderstanding? Let's take a look at a new way of seeing reality, one that goes way beyond the equation.
So first things first, let's start by questioning something we all kind of take for granted, this idea that the universe is governed by laws. I mean, we talk about the laws of physics as if there's some cosmic rulebook, a set of instructions that the universe has to follow. But is that really what's going on?
I mean, really think about it for a second. Does a particle or a field or a galaxy actually consult an equation before it does something? The whole idea of obeying suggests some kind of command structure, like there's a cosmic CEO telling everything what to do. And that framework, well, it might not exist at all. It's totally possible we've been looking at this whole thing completely backward.
In this quote it gets right to the heart of the matter. The universe isn't following instructions from some grand cosmic textbook. Nope. The idea here is that reality is driven by the intrinsic properties of matter and energy. Things act the way they do because of what they are, not because they're following some kind of external script.
Okay, so if the universe isn't following a set of laws, then what in the world are our equations? And this is where we get to a really fundamental confusion, one that's sitting right at the heart of modern physics. We might have been mistaking our models for reality itself.
This confusion actually has a name. It's called the formalist fallacy. It's this delusion that our mathematical descriptions, our amazing equations, are the things actually driving the universe. But here's the thing, they're not. They're human-authored formalisms. They're incredibly sophisticated descriptions that we created. They aren't the engine of change.
You know, there's a perfect analogy for this. Our equations are like these incredibly detailed, unbelievably accurate maps. They help us navigate the physical world with jaw-dropping precision. But somewhere along the way, we started to believe the map is the territory. And it's not. The map isn't the landscape, and the equation isn't the reality.
This table just lays out the two worldviews so perfectly. Over on the left, you've got our mathematical models. They're human-constructed, and the big star of the show, the primary actor, is the equation. But look at the right column. That's the proposed reality. It's inherent in nature, driven by intrinsic traits, and the primary actor, it's the material itself. You see the disconnect?
So what happens when you mistake the map for the territory? Well, you run into a huge problem. You end up with a field that looks fantastic on paper, but it lacks any real-world substance. The source material for this explainer calls this the materiality gap. So here's the problem in a nutshell. If a field is just a set of numbers in an equation, a pure mathematical abstraction, then it's fundamentally hollow. It has no physical stuff to it. So how can a set of numbers, all by itself, actually push or pull or cause any real change in the physical world? The short answer is it can't.
And this leads to a pretty wild conclusion. The change we see happening in our equations is more like a movie than it is reality. It's just a series of shifting frames, numbers changing from one value to the next. It's a simulation of a process, not the actual physical process itself.
So what's actually missing from our mathematical fields? Real physical properties. To cause change, a field needs things like intrinsic elasticity, the ability to store and release energy. It needs elastic resistance, the ability to push back. And crucially, it needs a substrate composition, the actual stuff that it's made of. And numbers alone, they just don't have any of that.
This creates another kind of fundamental mismatch. Our gut instinct, our intuition, tells us that nature is smooth and continuous, like a flowing river. But our math, which is based on numbers, is inherently discrete. It's made of separate steps, like stepping stones. There are always gaps between one number and the next. So it seems like even our most basic tools for describing reality don't quite line up with how reality might actually work.
So, how do we fix this? How do we get out of this mess? Well, the path forward requires a pretty radical shift in how we think. The source material calls this reversing the inference.
And here is that paradigm shift, laid out plain and simple. On the left, you've got the old way. We treat the field as the primary actor, the thing that obeys the laws. But the new path, on the right, completely flips this on its head. It says the underlying material is the primary actor, and the field is just the effect that this material generates.
So a field in this new view isn't a fundamental cause of anything. It's a secondary effect. It's the observable phenomenon that pops up from some deeper material structure.
You could say that for too long, we might have been studying the shadow on the wall instead of the object that's actually casting it.
This way of thinking points to a whole new research agenda for physics. The goal is no longer just about refining abstract equations. Instead, as you can see here, we need to start prioritizing the investigation of the substrate composition that's underneath the fields, start treating those fields as secondary effects, and root all physical properties in some kind of real, tangible substance.
So where does this all leave us? What does this mean for the future of physics? Well, it means we need to shift our focus away from abstract math and back to concrete reality. And that could open up an entirely new and exciting frontier of discovery.
And that brings us right back to where we started. The universe isn't performing from a script that we wrote for it. It's just being itself. And that suggests our job as physicists isn't to be the playwrights, but to be the detectives, trying to understand the actor.
So if there's one thing to take away from all this, it's this. Equations describe, but they do not drive. A field that only exists as a mathematical concept, one that doesn't have a material basis, can't actually do anything. It's just the description of a ghost.
Which leaves us with one just huge, profound question. If we look beyond the equations, beyond the map, what is the fundamental stuff that generates the fields, the forces, and the entire reality we experience? What is the universe truly made of? And you know what? That might just be the next great mystery for physics to solve.